Objective number 2, the confidence intervals for variance and standard deviation. So we look at the formula. We can see that sigma square or sigma square represents for population variance, and sigma is the population standard deviation. The two formulas, they are very similar of each other. If you notice that if we take the square root of the first formula, we will get the second formula. So it depends on the problem. If the problem asks me for the population variance, then I will use the top formula. If the question asks me to find the confidence interval for population standard deviation, I will use the second formula. The degree of freedom is n minus 1. Now we look more detail in the formula. N is the sample size. S squared is the sample variance. You recall from chapter 2, if we want to find the variance, we just do equal VAR. For example, you got the number is 2.3. This is mean S squared is 2.3. So the technology already squared the number for you. Okay, so you don't have to square 2.3 anymore. It's already square from some number. Now we read the problem in example number 2. I begin to read the question first. We want to construct 95% confidence interval for population standard deviation. For population standard deviation, sigma, we will use the second formula. We write down the second formula is square root of n minus 1 times s squared divided by chi-square, and chi-square of alpha divided by 2. I will explain to you later. Let's copy out the formula. And then n minus 1 times s squared over chi-square of 1 minus alpha divided by 2. Okay, so we're gonna call chi-square to the right and chi-square to the left will be easier. So chi-square of 1 minus alpha divided by 2, that will be for the left. And chi-square of alpha divided by 2 is for the right. We're gonna put in the right on the left side, and we will put in the left on the right side. So we're gonna use chi-square right and chi-square left. Okay. Now we will plug in the number. So we have 7 concrete blocks. So we have n is 7. So we're gonna put 7 minus 1. And then S squared is the variance for sample. So we have 7 concrete, they are the sample. You will use equal STTEV if you want to find the standard deviation. But for this problem, we just go ahead and use the Excel, and we just do VAR to find the variance S squared. The number that you got, if you use VAR, is 2,699 2.8648. This number already square from some number, so you do not need to square anymore, okay? So that is the s square. Now the chi-square right and the chi-square left, we need to calculate using the 95% confidence interval. We're gonna draw the shape first. We're gonna put 95% in the middle. That means the right tail is 2.5%, the left tail is 2.5%. The chi-square right is on the right side, the chi-square left will be on the left side. So what do we do is for the chi-square right, we will find it first because it's shade on the right side. We know the shade on the right side is 0.025. We have 7 concrete. We will look at 6 degree of freedom because degree of freedom is n minus 1. So we go to the table at the top and we will do the color orange also because 0.025 and the degree of freedom is 6. We map them together, we get 14.45. For the chi-square left, it's gonna be 97.5, and that is the orange color also. So then the number that we got is 1.24. When you plug into the formula, the one on the left side, you will input the right chi-square, okay? So that will be 14.45 and then 1.24. The chi-square value is already squared for you. So once again, don't square the number. 14.45 is a chi-square value already. Now you simplify this. You will get 33.48 and 114.44. We will answer the problem. We are 95% confident that the population standard deviation is between 33.48 and 114.44.